Hi, I've done a predicted paper. My name's Martin New from Stoke College. I've done a predicted paper for Tuesday's AQA Foundation tier paper. So what I'm just going to do is you can find that paper on our Moodle or on Padlet or probably with test resources. So it'll give you a good chance to go for the type of questions that are likely to come up on Tuesday's exam because they've not already come up in paper 1 and paper 2. So we'll have a look through it. What you can do is look at the questions first, pause it, have a go, and then look at the actual answer afterwards if you want to. Okay, let's get started. So here's a list of numbers. Write down two numbers in the list that multiply to equal 100. You've got a calculator, you can probably do that without a calculator, but two numbers multiply to equal to 100, so just highlight those things. So looking at that, looks like 4 and 25 will do that, so nice, easy, straightforward start. Write down a multiple date, so anything in the 8 times table, relating back to that again. So looking at that, 40 is in the 8 times table, so basically what you could do is calculate a paper. You must use your calculator. You could, if you weren't sure, you could just divide those bigger numbers by 8 and see if it gives you a whole number answer. So there you go, that's 40 there. Write down the mathematical name of this shape. So this is where my bit about being a maths teacher is challenged, because I have to write down a parallelogram, and I think I've probably spelled that correctly, but parallelogram has two pairs of parallel sides like that, so it's just like a rectangle, but it's on a slope there. It is also a quadrilateral, so even if you've got any sort of four-sided shape and couldn't remember, put down quadrilateral, that will probably do the trick. So we've got some mathematical names of some solids. So this one here is a cuboid, so cuboid there. And the next one down is a cylinder. So get to know your solids. Okay, it might be a cone. Always think of an ice cream cone for that one. Okay, so next questions. Again, fairly straightforward questions towards the start of the paper, that's what it'll be. So have a go at all of them. Circle the word that's missing from this sentence. So looking at that, 3, 9, 11, the one that fits for those is odd numbers there. Circle word that's missing, again, looking at those, 4, 9 and 25. So 2 squared is 4, 3 squared is 9 and 5 squared is 25, so it looks to me like those are square numbers. And then those at the bottom, 2, 11 and 17, all of those numbers only have 2 factors, so they're all going to be prime numbers because a prime number only has 2 factors. Okay, so not too hard at the moment, at the early stages of the paper. This is what it's normally like. Shade 50% of the grid. Well, there's various ways I could do it, but I'm just going to shade that bit there. And then work out 25% of 120. Again, you can do that on your calculator. Most of you will probably know that 25% is equal to a quarter. So we've got a quarter, 120 divided by 4 there, and that's going to give us 30. So yep, there we go. So the answer to that one's 30. Pen's breaking up a bit there, but I'll hopefully get it back. So write 80% as a decimal. So if it's 80%, what we'd do there is we'd divide that by 100, and that, you'd do it on your calculator, would come out like that, 0.8. So the first part of the paper is always going to be fairly straightforward questions, but fairly easy ones. So, and then the middle bit, we'll get into a bit of problem solving. Then the end, again, it's fairly straightforward, but harder. Okay. So we've got a probability type question here. 2 sets of cards, set A and set B. One card's chosen at random, so from each set, and the cards are added together to give a score. So basically we can see here that 1 plus 0 is 1, 3 plus 0 is 3, and then 4 plus 1 is 5, so I'll put 5 there, and then that's 5 when we add along there, and then we've got 7 plus 0, so that's 7, 5 plus 2, 7, making a nice pattern here, so yeah, that's great. And then 4 plus 3, 7, 1 plus 6, 7 there. So now we've got 9 plus, sorry, that's the answer, 3 plus 6, which is 9, 4 and 5, 9 again there, 7 and 4, add those together, 11, again 6 and 5, 11, and then 6 and 7, 13. So what's the probability that the score is even? Well, when we look at probabilities, we're going to look at the bottom number there. That's all the possible ways, outcomes that we can get. And we're looking for, in this, the probability that it's, so it's probability that it's even there. And that, well, actually, I can't see any even numbers in there. So that's going to be 0 out of 16, which if we do divide 0 by 16, then we're going to get 0. So it's a probability of 0. Basically, there are no even numbers in there. So then it's the probability, it's not a square number. So what I'm going to do here is now I'm just going to look at that table again and look at all the square numbers. So 1 times 1 equals 1, that's a square number. 3, 5, 7, 9, there's another square number. So circled those, and what we've got this time is 11, 13, well they're both primes, so not square. We've got 4 out of the 16 there, so the probability is 4/16. So we'll just write that down at the bottom there. So our answer there is 4/16. Nice that really as well, because those are the sort of questions where you just follow some simple instructions with that. It's called a sample space diagram, that. So it's nice that to just get to sort of pick up some nice marks. Okay. Right, okay, so this is a speed, distance, time, so a compound measures thing. I often remember with one of these SODIT diagrams, so, but you'd probably be able to look at this and think to yourself, well, wait a minute, if the average speed is 64 miles per hour, yeah, and somebody travels 32 miles, that's actually going to be half of what they would have travelled in an hour. So that's going to be 30 minutes or half an hour. So that's okay. So with a solid triangle, we could basically be saying, well, if it's distance, we just cover distance up and we're looking for speed times multiplied by time. And then if it's time, we just cover up the time, and then it's distance divided by speed, or speed, it would be distance divided by time. So looking at this one again, if the average speed is 42 miles an hour, then in 1 hour it's going to travel 42 miles. And actually we've got 20 minutes. Well, 20 minutes, if you think about it, is a third of an hour. So a third of 42. So it's going to give us 42 divided by 3, if you're doing this on your calculator. So that's going to give us 14. So it's basically adding the 14 onto that, and that's going to give us 56. So he's going to actually, or she, is going to travel 56 miles in an hour and 20 minutes, or an hour and a third. So we've now got a pie chart, and this is an interpreting a pie chart. Pie charts haven't come up yet in any of the questions at all in any sort of form, so highly likely to come up. So make sure you can work out how to do pie charts and how you can do actually interpret them as well. So pie chart shows the sports played by 30 boys. How many boys play, so it's 30 in total, I think. Let me just have a quick check on the pie chart shows the sports played by 30 boys. Okay, so the whole thing is going to be 30, so that's 180 there, that's a straight line. So if half of them, that's going to be 15 boys there. And then we've got 15 boys over this bit, and now basketball. So we're looking at how, oh, that's it. How many boys play football? So yeah, we've got 15 boys there. Yeah. Oh, and then how many boys play rugby? So this bit here is going to be, well, we've got 60 degrees, and then we've got 120 degrees there to make that 180. So that 15 is going to be split, and we've divided that by 3. So there's going to be 5 playing basketball and 10 playing rugby. Okay, so you'd be able to use your calculator on these, but they're the sort of questions you probably can work out in your head. So, so 15 there for 15 boys, and 10 boys for the next bit. Okay, so this is right. Okay, so this is a nice little graph, and it's a tank that's being filled up with water at a constant rate. The tank's a cuboid of height 80 centimetres, so that's our 80 centimetres here. So anytime we get into this sort of question, you know, make sure we highlight that information, just write it out so you can see it clearly. The tank's full after 15 minutes. Sita draws this graph to show the depth of water during the 15 minutes. Okay, aye. I'm sort of thinking that maybe needs to be a straight graph. Anyway, make 2 criticisms of Sita's graph. So my first criticism, that actually this should be a straight line, because as the tank fills up, it's going to be filling up there, so it would actually end up being a straight line there. A second criticism, can we see a second criticism? Well, yeah, actually, there's no unit there. So the unit should be, I think it was, let's just go back up there. It was, yeah, so it was centimetres. So the unit there should be centimetres. Yeah, it's just centimetres in height. So yeah, so the unit's not on there. So that's the centimetres that should be on there. So the depth should be in centimetres. So that'd be a criticism. And actually, if you get asked to do a graph like that, you might be given the information and actually have to create the graph. So make sure that you're drawing it in the correct way. Okay. Function machines, a little bit of algebra here really, but function machines tend to turn up in most of the AQA GCSE exams. They haven't turned up yet, so I'm hopeful they're going to turn up on Tuesday. So what you do here is, we've got a number machine, work out the output when the input is 9. So 9 plus 6, so that's going to give us 15. And then we're going to divide that by 2. So we divide the 15 by 2, and that gives us 7.5. So the output is 7.5, so put the answer there. And then we've got the same number machine, and the output's 9, but we've got to do it in reverse now. So when we're doing it in reverse, what we're actually going to get is, we're going to get, instead of divide by 2, we're going to get the inverse of that, we're going to get the opposite. That's going to be times by 2, because that was plus 6, we're then going to take 6 away there. So we're starting with 9, so it's 9 times 2, which is going to give us 18, and then 18 take away 6, so that's going to give us 12. So our answer to that one is 12. So a nice couple of marks to pick up there. Remember, when you're doing these questions, you get onto the big questions, and you know, a grade is around about 10 or 11 marks. So 5-mark questions, they're going to give you half a grade. So well worth having. So question 10, we're coming on to a fairly straightforward probability question. So there are 25 counters in a bag, 12 are red, 5 are green, and the rest are white. A count is chosen at random. Work out the probability that it's white. So probability that it's white is going to be, well, actually there are 25 in total, and 12 are red and 5 are green, so 12 plus the 5 is 17. So that means that we're going to have 8 that are white. So the probability there is 8/25. So fairly straightforward there, simple probability question. Likely to get a simple probability question. It's we're hoping anyway. Okay, so these are parallel lines really, and I put this in just as a little bit of a nice learning tool as well. So which angles are vertically opposite? Circle your answers. So the vertically opposite ones are A and B there. So that's that one. And then the next one is which are alternate. So the alternate ones are this. Remember, we used to be able to call them Z angles, but you can't call them that. You call them alternate angles, but it gives that Z shape. So that's B and C there. And I think the next one is which ones are corresponding. So going back, corresponding gives you that F shape. So the corresponding ones would be there, creates that F. So those are the corresponding ones, and that would be A and C. So A and C for those bottom ones there. So nice, just remember, you really need to learn, if you don't already know, those parallel lines angle facts. So vertically opposite, alternate, and then corresponding. Okay, so how many marks is this question? This looks like one of those. So 4 marks, so it's almost a third of a grade if we get this one. So there's quite a bit of information there. So coal is sold in packs of 6 or packs of 8. We've got a nice picture to remind us about that. A pack of 6 for £1.95. But if we buy 2 packs of 6, it would be £3.50 for the 2 packs. Now with these here, we've got 1 pack, £8 for £2.64, and then 2 packs of 8 would cost us £5. So actually, I think that £5 and that £3.50 there are the key bits. So what's the cheapest way to buy 48 cans of cola? And you must show you're working. That's in bold, so you can't just say, yeah, it's the 8 pack. You'll get no marks for that. But at the end, you must give an answer. So what we've got is, let's work it out for the 6 pack. So 48 cans. So we'd have to buy how many packs of that? We'd have to buy 8 packs of that, because 8 fours, 8 sixes are 48. So that would mean that actually if we were buying 8 of those, that it would be 4 lots of 2 packs. So it would be 4 times £3.50. And if we did that on our calculator, we'd find that that would come to £14. And then looking at the 8 packs, so we'd have 6 of those, so that would be 6 times the 8 packs. That would give us 48, and we'd need 3 lots of 2, so that would be 3 times £5. So 4 marks, and that gives us £15. So which is the best value? Yeah, we've got to say which is the cheapest. So it's the 6 packs, best value. Now when you get these sort of questions, when I'm marking mocks or looking at students' work, they often do all the working and then forget to answer the question, and that's normally a mark right at the end of it. So just make sure that you get 6 packs best value. Okay, brilliant. Third of a grade there. Now we've got a little bit of algebra here. Everybody does these in slightly different ways, but we've got x over 3 minus 9 equals 12. So some people just flip the 9 over the equal sign. Some people start hiding things and various sort of ways of looking at it. So all I'm going to do is I'm going to say, well, to get rid of this minus 9, what do we have to do? So we need to add 9 to this side. So 9, take away 9 there, that means there's nothing. Set of scales, that's what an equation is basically showing us. Whatever we've done to one side, we've got to do to the other. So we're going to add 9 to the other side. So that then gives us x over 3 equals 12 plus 9. So that's going to give us 21. And now what we've got to do is we've got to say, well, actually, we've got x there at divided by 3, and it gives us 21. So one way of working that out would be to say, well, let's have a look at this. And because x is divided by 3, if we times this by 3, then 3 divided by 3 is 1, so that leaves us with x. And whatever we've done to this side, we've got to do the same to this side. So that's times by 3 there. So 21 times 3 is going to give us 63. Now we just always just check when you've done an equation like that. Nice 2 marks, but 63 divided by 3 gives us 21. Take the 9 away and that gives us 12. So we know, we're sure that we've got it. That's one of the nice things about maths, is being able to just check and be sure that you've got some marks there. So let's have a look at so starting to get a little bit harder as we get more into the paper. So factorize fully, and if it says factorize fully, always be a bit wary because it's 2 marks, so make sure that you take everything out from this. So factorize just means put the brackets back in, doesn't it? So what can we see that's common to both of those? Well, I can see that both of those are multiples of 3. Yeah, so the 9 is a multiple of 3 and the minus 6 is a multiple of 3. But also we've got a common factor of a in both of those 2 terms. So we'll take a outside the bracket. And then what we're going to do is we're going to say to ourselves, well, 3a times what is going to give us 9a squared? Well, 3 times 3 is going to give us 9, and a times a is going to give us a squared. So inside the bracket is 3a. And then for the second bit there, we've got 3a, well, it's going to be minus there anyway, so 3a times what is going to give us minus 6a. So I think that's 2 lots of 3a there, and that's your working done. So sometimes people might only take the 3 out or the a out, and you probably get 1 mark for that. But if you see that word fully in a factorisation, think to yourself, oh, there's probably going to be a little bit more to it than that. Okay, so next bit we've got fairly straightforward again, but you need to know this, so work out the area of a circle. So the area of a circle equals pi r squared. So we've been given the radius, so that's 6. So a equals pi times 6 squared. So a equals, well, 6 squared is 36. So we could actually say that that's 36 pi. So we just need to multiply by pi to get, it doesn't say give it in terms of pi. Probably it may well take both answers. So I'm just having a quick glance at the mark scheme here, but yeah, so let's have a glance. Yeah, 36 pi would absolutely be fine, but if you want to multiply that by pi, and then get the, you're going to get something like 113.0973355. So if you got that, you would probably put it as 113 would probably be okay, meters squared, or 113.1 meters squared there. So nice 2 marks there, so long as you know your formulas. Obviously, if it was a circumference, it would be pi times the diameter, or pi times 2r. Okay, so question 16. 18. These sort of questions come up quite a lot. They're often 5-6 mark questions. This one's a 4 mark question, but 82 children visit a sports centre. 50 of them swim. At least 1 adult is needed for every 12 children who swim. So I'm going to do, going to look at that, and then the other. So those are key bits of information there again. The other 32, so the 50, they dance, and they need at least 1 adult for every 15 children who dance. So what's the minimum number of adults needed for the 82 children? So we're going to look at this bit first here, and there's 12 children there, so 4 times 12 equals 48. So 4 adults wouldn't be enough. We'd have to have 5 adults there. And then the second bit, 32 children dance. At least 1 adult is needed for 15 children. So we'd need 2 adults for 30 children. So we're going to need 3 adults, because 2 won't be enough. So basically, it's a nice addition there. Add those together, and away we go, and that's our answer. Yeah? So nice, easy 4 marks. Nothing complicated in that. No difficult concepts. You haven't got to remember any formulas. All the information's there. Just take your time unpicking it and reading it, and then you can have yourself 4 nice marks, or even 5 or 6 sometimes. Okay. So Jodie's pay is £315 per week, and she works for 37.5 hours per week. Work out her hourly rate there. So key bits of information again. So 2 marks. What we're going to do with that, we're going to do 315, and we're going to divide that by 37.5. So I'm not going to do that one in my head. 315 divided by 37.5, and that gives us 8.4. So actually what that would be, because it's money and it's her hourly rate, it would be £8.40. Okay, so Jodie wants to work out her yearly rate. She says there are 4 weeks in a month. So I'll multiply 315 by 4. Yeah, okay, sounds reasonably logical. And there are 12 months in a year, so I'll multiply the answer by 12. So 315 times 4. I'm just going to check that she's got that one right. 315 times by 4 times by 12. And that gives us, yeah, she's right in that, 15,120. Does a method give the correct amount for a yearly pay? Show working to support your answer. Well, no, it doesn't actually, because 4 times 12 equals 48. So by my reckoning, she's not been paid for 4 weeks of the year. So what she actually needs is that we have 52 weeks in a year. So it's going to be 52 times 315, and that will give us, so 52 times 315, and that gives us 16,380. So therefore 16,380 is greater than 15,120. So let's go back to this question. Here's the question, there's the question mark, boom, we need that. So does her method give the correct amount for her yearly rate? No, because she's missed 4 weeks. You can say that, but it doesn't have to be, it's not like an English exam, it doesn't have to be paragraphs and paragraphs, but make sure that you answer it. Like I said before, one of the problems that people make with these is they forget to actually say yes or no at the end of it, and the reasoning for it. Okay, so I wonder how many marks that one is. Yeah, 4 marks again, so very nice, yeah. Oh, and we need to, yeah, so I'm just using an example here of me not actually answering the question properly. So we've got to tick a box. So, no, her yearly pay is more, yes, or no, her yearly pay is less. So actually her yearly pay is more, so it's that box there, yes. So I'd have only got 3 marks for that one. So, question 18, this is one of those vector ones again, so adding or subtracting vectors. So that's A there, and we've got B there, so it's A minus B, and what we're going to do here is we've got our vector like this, so we've got 5 and minus 2 there, and we're going to subtract, so we've got minus 2 there, and 3 there. Again, you can use your calculator for this, but what we're actually going to do is we treat these numbers completely separately here. So it's just the top numbers. So 5, take away negative 2. So those 2 negatives are going to give us a positive there. So that's going to be 7. And then negative 2 plus 3. So that's going to give us 1. And hopefully that's on there. Yep, there it is. And that's it. Now that's 1 mark, but even if you don't really know that much about vectors, that's very easy, nice marks to pick up. And it does sort of sit, so often you might not see it in the form A minus B, you might just see a minus sign between the 2 vectors. Grand. Okay, so now we've got solving another equation here. So these are fairly straightforward, don't really need a calculator for these, but what we're going to do is, well, we want to get all the x's on one side of it and then all the numbers on the other side. So I'm going to look at this side first. I've got 6x, so that's plus 6x, so the opposite of that is minus 6x. So if I do 6x minus 6x, that's gone. And then if I do minus 6x from this side as well, then what we've actually got is we've got 8x minus 6x minus 3 equals minus 9. So if we simplify that, 8x minus 6x gives us 2x. 2x minus 3 equals minus 9. So now we're going to look at it and think, well, how do we get rid of the minus 3? So the opposite of taking away is plus. So we're going to add 3 to that side. So negative 3 add 3, that gives us 0. So 9 negative 9, of course, yeah. So negative 9 add 3. Remember which way this is going to go. It's going to make the number bigger. So it's going to be, so adding 3 there to that side. So then we've got 2x equals negative 9 add 3. So that's going to give us negative 6. So be careful of that. So now we've got 2 lots of x. So really we're thinking, well, 2 times x would give us minus 6. So you might just spot straight away that it's negative 3. So 2 times negative 3 would give negative 6. If not, then just divide through by 2, because 2x is 2 times x. So divide by 2 there. And then whatever we've done to this side, we divide by 2. So x then equals negative 2 divided by 6. So that's going to give us negative 3. So, okay, so our answer down there is negative 3. Try and make it nice and neat and keep your equal lines there. do it neater than I've done it on here, but that's because I'm just working on a board. So, okay, yeah, next question. So, area of the triangle. Area of the triangle hasn't come up. Now, area of the triangle, fairly straightforward. It's also looking at doing this to one decimal place. So, basically it's the base times the height, because it's half of a rectangle, really, and then we're going to divide by 2. So, 8.6 centimetres times by 5.2 centimetres, and then we divide that by 2 there, because a triangle is half of a rectangle, and we're going to get 8.6. I probably can't do this one in my head at the moment, times 5.2, or at any time probably. So that gives us 44.72, and then that's divided by 2, so we can divide that by 2, and that gives us 22.36, and it's centimetres, so it'd be centimetres squared, because it's area, and we've got that down there. Now, the key bit which I underlined at the start, so I'm not just going to race in and put the mark in there, is to one decimal place. So, when we're going from the decimal point there, we go one place and to 2 places, and then we're going to look at that. If that's 5 or more, then that goes up. It is, so that goes up. So it's actually going to be 22.4, so 22.4 centimetres squared. Wonderful. Another 3 marks for a very straightforward thing. So remember, all you need to remember with area of the triangle is area of a rectangle, base times height, and then you just divide it by 2. Brilliant. Oh, I'm absolutely certain one of these is going to come up. So we've got 240 people go to a rugby match. These frequency trees, new to the sort of GCSE specification with a new 9 to 1. But you can get marks out of these really easily. Even if you don't get all of them, you can get most of them. So 183 people support the home team. The other people support the away team. So first of all, we can get a mark straight away there. So 240, take away 183. So that's going to be 57. And now we've got 162 of the supporters are male, and 45 of the away supporters are male. So we can actually fill in the rest of this now. So we could go down here, because there's 56 away supporters, 57. So actually 57 take away 45, that's going to give us 12. And then up here we know that there are 162 supporters that are male, so that would give us 1571. Brain's gone now. So, that would give us 162. And use your calculator. It's dead important to do that. Minus 45, and that. No, it's not. So 162 minus 45, and that's going to give us 117 there. And we know that actually this 117 should add up with that. Those two, the male and female, should add up to 183. So 183 minus 117. And that's going to give us 66 there. So female supporters 66, so that's giving us 78 female supporters in total. So if I just check that, going up to the top there, and just check what my so it's 240 people. So really, as our check now, all of this in the end column should add up to 240, so 117 plus 66 plus 45 plus 12, and that gives us 240. So just by adding those up, I've checked it. I know, I'm pretty sure that that's probably right. So I don't know, maybe that's 4 marks, that one. Just having a glance there. Yeah, 4 marks. So you'd definitely be getting a mark for that one there. And, well, probably actually a mark for each box. So nice, easy way to get some marks. Nothing too complicated in it, just being able to use your calculator and working out what it should be. So I think, you know, loads of you can get that right. So two triangles, these two triangles are congruent. What do we mean? They're not drawn accurately, so don't start measuring them. What do we mean by congruent? Well, we mean they're identical to one another, and if we moved it around, we rotated this, it would sit exactly on there. All the angles are the same, and all the lengths of the sides are the same. So that's what we mean by congruent. So what's the size of angle P? Well, we've got angle P up here, and that's going to be, so we've got 84 over here. So in a way, one nice way of doing this is saying, well, actually, that's the equivalent of C over there, yeah? And then we've got our 8 centimetres there. So we know that from C going along there is 8 centimetres. So that would be 8 centimetres. Oh no, that's our 8 centimetres there, isn't it? So that's not going to be. We've got our 84 there, so that's 8, and that is going to be 5 centimetres. It's just throwing me just because the orientation of them. So now we know that the one over there, that last one's going to be 10 centimetres there. So the one, the angle that's at the end of the 8 centimetre line, so 84, then 47 is going to be along there, and then our final one there is going to be, at the end of the 5, is going to be 49. So I think we've got it all sorted there. So what's the size of angle P? Well, angle P up there is 47. Okay, and then I think, oh, is that's probably, maybe there's another question as well a little bit further down. Yeah, so what's the length of PR? So PR is, just going back up there, so PR is 10 centimetres. So that's one there. So 2 marks there for fairly straightforward stuff, but just remember the word congruent. Similar is if they've got the same properties, the angles are the same size, but it's a triangle that's a little bit bigger or smaller. Here are the first 5 terms of a linear sequence. Work out the nth term. Now, with this one, so as soon as we see nth term, it's going to be in terms of algebra, and I'm looking at this and thinking, well, the difference between this is 6 here, difference of 6, difference of 6 there. So that's fairly straightforward arithmetic progression. That sort of question, arithmetic and geometric progressions came up in the other one, so it's unlikely you're going to be asked to name that sort of thing. Now, what that means is that 6 will be, in an nth term, will be 6n, because it's something to do with the 6 times table, but it's not quite the 6 times table, and what we could say is, well, actually, if we put the 6 times table here, so we've got 6 there, 12 there, 18, and 24 there, and so on, and 30 there, that our nth term sequence is always, yeah, you can probably spot that, 3 more on each time, so it's going to be 6n plus 3. So that's, if you get a nice linear sequence like that, then just find the difference, and that's the number that you multiply n by, and then just see how close it is to that times table and either add or take from. Now we've got a nice expanding and simplifying. So we're starting to make our way through the problem solving type questions now, and we're moving more into the end of the paper questions, getting a little bit harder, but still able to do them. Now, lots of people have different ways of doing these questions. So this is an expression here that we've got to expand and simplify. It's a double bracket thing, so it's going to give us a quadratic expression. So various people do these differently. So what we're doing there is x times x. So x times x is going to give us x squared, and then we've got x times negative 4. So that's going to give us negative. So that's going to give us negative 4x there, and then we multiply the second term by both of the other two terms in the other bracket. So that's going to give us 5x, and then 5 times negative 4 is going to give us minus 20. And all we've got to do there is, so 2 marks, you'll get a mark if you've got that. Now we need to simplify it, so collect the like terms, so x squared there, negative 4x, oh, forgot the x there, negative 4x plus 5x is going to give us x, and then we're going to get negative 20 there. Okay, so the next one we've got to do is we've got to, so we put our answer in the answer column there. It's in the answer box there. It's always worth having writing it in the answer box. It's there for a reason. So even though you've done the work and you might have written it up before, make it easy for the examiner. When they're tired at night marking these things, they need to be able to see things quicker and easier. They do mark them very thoroughly, but make it easier for them. So we've now got to solve a quadratic, so a double bracket like that. And the way to solve this is to say, well, actually, we're going to get 2 answers. So normally in a linear equation we only get 1 solution. With this we're going to get 2 solutions. So to get an answer of 0, what do we need? We need to make sure that actually one of these brackets is 0 times whatever's in the other bracket. Because to get an answer of 0, the only way to do it is a number multiplied by 0. So what we can say is, we can say 8 minus x is equal to 0, or we can say x plus 7 is equal to 0. Now, you'll probably be able to see the solutions there quite easily. So, if we add 8 to that side, then we get x equals 8. And then over here, we take 7 away from that side, so we take 7 away from that side. So x equals negative 7. So another nice, easy mark, but it is the sort of question I think could come up with a quadratic, but it's up into that grade 5 boundary, but it's a straightforward one. So then we'll just make sure that, so x equals 8, x equals negative 7. Okay, so starting to wind in towards the end of the paper now. Oh, Venn diagrams, yes, Venn diagrams likely to come up. 50 students are asked if they study geography or history. The Venn diagram shows some information about their answers, and there's something in the middle there that's in this bit that's saying 7. And the first question is what does the 7 on the diagram represent? Well, that's showing that there are 7 students that are studying both geography and history. So 7 students studying geography and history. So that's basically the answer there. I think that's probably a 1 mark question. So yeah, so 7 students doing geography geography and history, should I say. So geography and history. So 20 students study geography but not history, and 19 students study history. So now we've got to think about this a little bit more. So 20 students, so this is the I think this is the geography and this is the history here. So 20 students study geography but not history. So we've got, this is geography here. So actually if we've got 20, that means that there's 7 of them that are doing geography but not history. So 13 there. So 13 plus the 7 gives us the 20 students that are studying geography, but not history. And the 19 students that are studying history. So there's 19 in there, but we know that 7 of them are also doing that. So 19, take away the 7, is going to give us 12. So we've got to complete the Venn diagram there. Now this is where it's fairly straightforward, but I've got to make sure that I've included everybody there. So there were 50 students to start with, so we've got 12 and 13, 25, 32, so there must be 18 students that are not studying geography and history, so they're going to be there. So there's 18 of them there. Okay, so nice 4 marks, and we all like doing our Venn diagrams, don't we? So, yeah, great. So now, question 26, solve simultaneous equations. You could get a simultaneous equation where the variables are different, where you haven't got one that's the same. This is nice. This is the likely sort of type of question that you'll get if you get a simultaneous equation on a foundation paper. So what we're looking at here is, we'll just call this equation 1, we'll call this one equation 2, and if we do, I'm going to do equation 1, take away equation 2 there, and what that means is that if we do 3x take away 3x, the x's disappear now from that, so 2y take away y, so because that's 2y take away negative y, then that's going to be a positive, so that's going to end up popping out there as 3y, and then it's going to be 10 take away 13, so we're going to get negative 3. So now, nice and straightforward, just divide through by 3 to find what y is, so that cancels out there, and that cancels out. That will give us negative 3 divided by 3, so y equals negative 1. And what we can do now is we can just go straight back into our equation, and we'll go back and substitute, sub it in equation 1. So what we're doing is we've got 3x plus 2 times negative 1. Hopefully that will give us, so we've got 10 there. So now that will give us 3x plus, well that's going to end up being 2 times negative 1, so that's going to be so that's negative 2x. Wait a minute. Oh, sorry, that's times, isn't it, of course, there. Yeah, so 3x plus 2 times negative 1, so minus 2 there equals 10, and then 3x equals 10 plus 2 there as that goes over the equal sign, so 3x equals 12, and then we're going to divide through by 3, so x should equal 4 there. So what we're saying is x is 4 and y is minus 1. Now, it's possible I could have made a mistake somewhere along the route there, so I'm going to check by looking at 3 times 4 and minus negative 1, and hopefully that will equal 13 there, so 12 These two become a positive plus the 1, and that equals 13. So, x equals 4, and y equals negative 1. So, there we go. Nice 3 marks. Even if you don't do all of it, and you subtract one equation from the other, you will probably get a mark or some marks of it. And that's the really important part about these papers. You know, the people that I'm working with you now are GCSE research students, and you've got to make sure that you get through this paper and do something, and you might pick points up at different points. So, getting towards the end of the paper, my voice is starting to go. I forgot to bring some water with me. So, question 27, Pete's buying a house. His salary is 36,000. It's not on a bad wage there. The bank will lend him 3.5 times his salary for a mortgage. This is 95% of the house price. So work out the house price. So first of all, let's see how much the bank will lend him for his mortgage. So it's 3.5 times his salary, which is 36,000. So this is the sort of question towards the end of the paper, 4 marks. So 36,000 times 3.5. So that's 36 times 3.5, and that's going to give us, it's going to give us £126,000. Now, what's that £126,000? That's what the bank will lend him, but they're saying that this is 90% of that. They'll lend him 90% of the house price. So this isn't actually the price of the house. So this is that reverse percentage type question. So what we're going to say here, and this is where the complexity comes in, but really easy to do. So £126,000 pounds actually equals 90%. So that's the 90% there. So what we're going to do to find out what the price of the house is, so quite straightforward. We could just, many ways of doing this, but we could just say, well, actually, if that's 90%, let's find 1%. So 126,000 divided by 90, and that's going to give us 1,400. So all we need to do now is to find 100%. That's the full price of the house. So to find 100%, it's going to be 1,400 times by 100. So fairly straightforward there. So this is the cost of the house, 140,000. Yeah, so that's the cost of the house there. So a reverse percentage type question there. You're not given the 100%, you're given a amount a bit above or a little bit below 100%, and then you've got to work out what 1% is to then find out what 100% is. So watch out for those. They're likely to, if you see a percentage question in at the end of the paper, it's likely to be a reverse percentage question. But doable, definitely. Okay. So what else have we got? I think we're coming in towards the end now. So factorize x squared minus 9x plus 20. So what this means is, 2 marks there, it's put it into double brackets. That's what we're going to, we know it's double brackets because it's got an x squared there, and it's got 3 terms. So what goes in the first bit is x there and x there, and then we're going to need to get some numbers, some factors that give us an answer of 20. So just quickly listing the factors of 20. So 1 and 20, 2 and 10, and 4 and 5. Now what we want them to do is, we want when whichever factor is right, we want them to be able to add these numbers up here, and it will give us the middle number. So I'm going to add those up. Well, 1 plus 20 gives us 21, 2 plus 10 gives us 12, 4 plus 5 equals 9. But oh, wait a minute, it's minus 9, isn't it, we're looking for? So, but when those two numbers multiply together, they'll give the end number. So to get a positive number there, get a positive 20, it's going to have to be two negative numbers that multiply together. Now, and then add up to negative 9. So I'm sort of looking at that there straight away. So and when so I'm going to put those in there. And yeah, so negative 4 plus negative 5 would give us negative 9. So that is our correct answer there. Lovely. And this is right at the end of the paper, and it's doable. It really is doable. So now, just asking us to solve that, and this is a little bit like the one before. So if this here is equal to this, and that's the same thing there again, then x minus 4, x minus 5 must equal 0. So if these are to equal 0, one of these double brackets has got to be equal to 0. So if x minus 4 equals 0, then x would equal 4. And then over here, x minus 5 equals 0. So x would equal 5. So our solutions there are 4 or 5. So there are three marks, 2 for getting that bit there. So yeah, nice. I think I think that might be the last question. Yeah. So we're all done. So that's good. So good luck with it. Have a go at the practice paper. Have a look at the links that I've got in the text that I've sent out to you, or go and find this paper on Tess. I've got it on a Padlet as well, but there you go. Have good luck on Tuesday and just keep revising. There's lots of good practice revision predicted papers out there. Go on to On Maths, go on to Corbett Maths, some really good stuff. Thanks very much, Martin Newton.